Okay, in this video we are going to do some challenging limits that involve using graphs and a lot of one-sided limits and compositions. So let's take a look at what we need to remember going into this to make sure that we can actually do them. So if we're going to say the limit as x approaches c of f of x is equal to L, right? The limit exists and is equal to L. That means two things are definitely true. The first one is that the limit as x approaches c from the left of f of x exists and is equal to L, which means that we have kind of this number line and we're approaching c from the left. So we're gonna have to think about that a lot. And then from the right also is involved. So the limit as x approaches c from the right of f of x is equal to L, which means, on a number line, we would be approaching from the right. So I'm gonna draw a lot of pictures that look like that as we go along. Let's see if we can do this. So we have a graph of f of x, we have a graph of g of x. My plan also, so I should say two things. One, I got these problems from some College Board produced material that they put out in like 2020 when things were kind of weird. And they're really great problems and I wanted to go through them with everybody. And the second thing is I'm going to try to make some generic graphs that you can potentially get a PDF of. I will link that below, so get a copy of that. And you can do the same kind of analysis on the actual graph if you want to. All right, so here it goes. We got a graph of f of x and a graph of g of x. We're looking at the limit as x approaches 5 of f of x. All right, so students often are kind of intimidated by this, or they immediately just say the limit doesn't exist and kind of hope that they're right. What we want to do is figure out what is going on as x approaches 5 of just f of x. And then we will deal with that outer f of x. So the first thing we're going to do is deal with that. So you might think of it as kind of a u substitution, where u is equal to f of x. We're going to figure out what u is doing as x approaches 5, and then go from there. So I need to figure out the limit as x approaches 5 from the left of f of x. So I'm figuring out what u is doing as x approaches 5 from the left. So if I'm going to approach 5 from the left, I'm going to do this. And you can see that graph is approaching positive infinity. So that's infinity. And that means, so that's our inner f of x is approaching infinity. So what I'm going to do is I'm going to say that that's our u. The original thing, so the limit as x approaches 5 from the left of f of x, is an equivalent to the limit as u approaches infinity of f of u. Now I just need to figure out what's happening on the graph of f as u approaches infinity. So remember, the variable that you're using is just a choice of how to spell it. It could be f of t, f of u, f of r, f of x. We're just choosing how to spell it. So it's the graph of f of x. It's also the graph of f of u. So I'm going to go back to that graph. If we go to infinity, you can see the y value is always 2. So that limit is 2. All right, now we got to do the same exact thing, but approach 5 from the right. So what I'm going to do is I'm going to put another graph of f up. So I'm going to do that in a second. Let me just write this down. So we're figuring out what the inner function is doing as x approaches 5. Then we'll figure out what the outer function does as that happens. So here's my graph of f of x again. I'm approaching 5 from the right this time, but it's still going to infinity. So that's still infinity. And then let's rewrite it again. So the limit as x approaches 5 from the right of our original, which is f of x, is equivalent to the limit as u approaches infinity of f of u. So this composition idea is a big deal. You want to break it down, look at the inner function, see what's happening. And then once you know what the inner function is doing, rewrite the problem and look at the new limit. So this became the limit as u approaches infinity. But again, if u is approaching infinity, we're still just going to be at 2. Because both of those are true, we can say the limit as x approaches 5 of f of x is 2. All right, so that's the general idea. And now I'm just going to do a whole lot of them. The very last problem is a little bit different, so if you just want to jump to that or if you want to watch all of them, I think it's probably a good idea, but totally up to you. Limit as x approaches 2 of g of f of x. So we're going to do the thing again. What is the inner function doing as x approaches 2? So we'll look from the left and the right. So first, the inner function is f. We're going to look at what f is doing as we approach 2 from the left. All right, so 2 from the left, go to the graph, approach 2 from the left. You can see as x approaches 2 from the left, the graph of f of x is approaching 2 as well. But kind of the question is how, right? That's going to be 2. So here's our number line, right? So if I'm approaching 2 think about it, as we approached 2 from the left of f of x, we started kind of at y equals 1, and then we got closer and closer to 2 as we approached 2 for x. So that means that we did basically this. So let me kind of rewind that so you can watch it again. So as I approach, watch on the graph of f of x, I'm drawing in kind of orange there. We're approaching. That means that on the number line, we're coming from the left of 2, right? So in general, if you're approaching with y values from below, that's from the left. And if you're approaching with y values from above, that's from the right. So this will be 2 from the left. All right, so the inner function is approaching 2 from the left. We're going to rewrite this thing. The original is x approaches 2 from the left of g of f of x. This is going to become the limit as u approaches 2 from the left of g of u. And that's going to equal, going back, let me rewind it again, I forgot. As u approaches 2 from the left on the graph of g, which is the graph on the right, we're going to approach 2 from the left. There you go. You can see that you're approaching 1. Technically, you're approaching 1 from below or from the left, but that doesn't matter because this is our final answer and we're not going to compose it again. All right, now we just got to do it from the other side. So here we go. Back to the original, we're going 2 from the right, looking at the inner function. What is that doing? So we go to the graph of f, we approach 2 from the right, like that. You can see the y value is approaching 4 from below. 4 from below is 4 from the left, but we can also do our number line here. So I'm going to draw again in orange. You can see there. So we're approaching 4, but from below, and from below means from the left. All right, and then we rewrite it. So the original was g of f of x. This becomes the limit as u approaches 4 from the left of g of u. So now we're going to go to the graph of g, which is on the right-hand side. We're going to approach 4 from the left. So 4 from the left, and you can see you're approaching 1. If you get the same answer both times, that means that that is the limit. So the limit as x approaches 2 of g of f of x is equal to 1. All right, let's take a look at another one. All right, limit as x approaches 0, g of x. So same idea. I need to first look at that inner function. So this is really the inner g function. So the limit as x approaches 0 from the left of g of x. So g of x is the right-hand graph. We approach 0. That value is approaching -1. But you're approaching from above, right? So here's our number line or sign chart. We're approaching from above, which means from the right. And there you go. So that's a little confusing because it looks like you're approaching from the left, but really you're approaching from above. So with y values, you want to think above and below. And with x values, you want to think left and right. And since we're approaching -1 from above, that's -1 from the right. Okay, so let's rewrite. So we get, this is our original, and we've just rewritten it as the limit as u approaches -1 from the right of g of u. So now I need another graph of g. So here we go. And I'm going to approach -1 from the right, which does that, and you can see that's approaching 0. Technically 0 from below or 0 from the left, but again, that's our final answer, so we don't care. I'm gonna need more space, so I'm gonna just duplicate everything kind of and do it again. All right, so now we're gonna approach from the right. We're gonna let x approach 0 from the right and see what happens. G of x. So this is the inner function that we're evaluating. I know it's g of x, but it's the inner one that we're dealing with right now. So approach 0 from the right, and you can see that's approaching -1. We'll do our number line, right? So -1, so I'm going to trace it again in orange here. We're coming from above, and if you're coming from above, that's really coming from the right. So above and right are basically the same, and below and left are basically the same. One's for x, one's for y. So from the right. So now we rewrite this. And we're going to write it in terms of u. Maybe on the next ones I won't make you watch me write this because I'm saying the same things over and over. So now we need to approach -1 from the right on the graph of g. So -1 from the right is approaching 0. Good. All right, so now if you remember, we already did the other one. So let me copy that over. So we know the limit as x approaches 0 from the right gave us 0. The limit as x approaches 0 from the left gave us 0. Because of that, the overall limit is going to be 0. So we're looking at limits from the left and the right, and we're doing compositions. All good stuff. Let's look at a slightly different one. So this will be a product. With a product, we're just going to hope that we need both the limit from the left and the right to exist. So we're going to hope that the limit from the left exists, the limit from the right exists, and if so, hopefully we'll be good. Let's see what happens. So I'm going to find the limit as x approaches -1 from the left of f of x times g of x. All right, so first up, what is happening to f of x as we approach -1 from the left? -1 from the left, you can see that's just approaching 0. Which you would think means it doesn't really matter what's happening on g of x, and that's like kind of true, unless g of x is going to infinity, in which case you have 0 times infinity and it's more complicated, but that is probably not going to be happening here, so let's look at g of x. So g of x, as we approach -1 from the left, you're just riding along that horizontal line, you can see that's going to give you 2, and then 0 times 2 is definitely 0. All right, let's do it again. So we'll go from the right this time. The limit as x approaches -1 from the right. So, I mean, part of making this video is I just want you to know that, like, you have to look from the left and the right, and you have to not freak out about it. Like, it's not as bad as you think. You don't necessarily have to, like, create the graph of f of x times g of x. You can look at them independently. These problems are a little easier than a lot of people think they are, and they just require a little bit more work than a lot of other people think. So we're going to do f of x, -1 from the right. All right, so there we go. And you can see you're just on that horizontal segment there. You're going to be at 1 the whole way. And then g of x as you approach -1 from the right. And you can see that's approaching 0, and 1 times 0 is 0, and because of that, we can say that the limit overall is 0. All right, let's take a look at another one. So that was a product. We just looked at each of them. This next one is going to be a sum, right? So let's see what happens. First, we're going to look at limit from the left. So to do this, we're going to deal with just f of x, see what it's doing, g of x, see what it's doing, and then add those up. Like if they both exist and are finite, we'll add them up and get our limit. So 2 from the left on f of x will be like this. So 2 from the left on f of x is giving us 2. And then 2 from the left on g of x is approaching 1. And we literally just do 2 plus 1. Not bad, right? So now let's look at the limit from the right. The limit as x approaches 2 from the right. So, and this is the kind of work that your teacher would want to see. All the way, I think on the last problem I did maybe like slightly worse work than I probably should have, but all the way through until that, I tried to do, really exemplary work so that you could be confident that you're showing enough. All right, 2 from the right on f of x. So 2 from the right on f of x is going to be in orange. And you can see we're approaching 4. Technically, we're approaching 4 from below or 4 from the left, but this is the final answer, so we don't care about that. And then g of x, we're going to approach 2 from the right. I'm going to use green. And there we go. That's approaching -1. It's kind of like, it's not really a miracle, but it's really neat when these give you like an actual answer and don't just not exist. I always think very hard to make these problems, very annoying. So kudos to whoever actually came up with them. So we got 3 both times, so we can say that the limit as x approaches 2 of f of x plus g of x is equal to 3. All right, let's take a look at another one. We're going to be back to a composition. So we got the limit as x approaches 2 of f of g of x. Here we go. So remember, when we're doing a composition, so this is good to bounce back and forth. Remember, when we do a composition, we're just looking at the inner function first, then we're going to rewrite the original limit. So we're looking at g of x. Limit as x approaches 2 from the left of g of x. We'll figure that out, and we'll use it to rewrite our original limit. So g of x, 2 from the left, there we go. That's approaching 1. And then we do care if it's from the right or the left. So just think it through. We approached 1, y equals 1, from below. From below means from the left. You can also do your little number line here. So I'm approaching 1, like starting at 0, and then 0.5, and then 0.9, whatever. I'm coming clearly from the left. So we will say from the left. rewrite. So I'm not going to make you watch that. There we go. We've rewritten it. The limit as x approaches 2 from the left of f of g of x is now equal to the limit as u approaches 1 from the left of f of u. So now we just look at the graph of f and we say what's happening as we approach 1 from the left. So 1 from the left gives us, we're just on that horizontal line, it's always 1. So that's going to give us 1. All right. Next, we have to go from the right. So remember, we're doing the inner function so we can rewrite the composition. Basically, you never want to deal with a composition, I guess, is when you're dealing with limits. Like, we really just want to deal with the inner thing, see what's happening, take that result, now deal with the outer thing as those results happen. All right, g of x, 2 from the right, so we trace, and you can see that you're approaching -1. -1, if you trace it again, -1 from above, which means from the right, but we can also do a number line, and we can think we were approaching -1, starting out at 0, and then -0.5, -0.9. So where is that on your number line? 0, -0.5, those are all to the right of -1. So we were coming from the right. So again, I mean, I'm really repeating this a lot, but when you're talking about y values, if you're coming from above, that's from the right. If you're coming from below, that's from the left. That's how it kind of translates. So this will be from the right. We're going to rewrite this, so I'm not going to make you watch that. Limit as x approaches 2 from the right of f of g of x is the limit as, this should really say u approaches -1 from the right. So that's, if I were grading this, I would circle that. I don't know if I would take anything off because that's like a small mistake, but maybe. It should really be a u. I'm not going to bother to change it. But u approaches -1 from the right of f of u. So we're on the graph of f again, and we're approaching -1 from the right, which is exactly what we did last time. Oh, no, it's not what we did last. It's the opposite of what we did last time, but it has the same result. Sorry. Last time we approached +1 from the left, which gave us a result of 1. This time we're approaching -1 from the right, which gives us +1. We get the same result, though, so that's the key. So same thing, which means that the limit overall is just +1. So we're good. All right, we're going to take a look at another one. How many are there? G, H, I. I got 3 more. All right, going to G. Here we go. The limit as x approaches 1 of g of x. Sorry, I got excited to read the next part. G of x times f of x plus 1. All right, so this is, we got a composition. We have a product, overall the limit's a product. But one of them, f of x plus 1, is actually a composition. People don't feel that way. It feels just I think that you mostly would think of this as a shift, right, to the left by 1 unit. I'm going to think of it as a composition. It's going to make my life, I think, a little bit easier, but let's see. So first up, we're going to approach from the left, right? And to do that, first let's just see what g of x is doing. So there's, on the graph of g of x, we're approaching +1 from the left. That's going to give us 0. So now the question is, does it matter what f is doing? Probably not. Although there is an infinity that could happen. Look at that vertical asymptote. So we got to make sure we're not hitting that. So now what I'm going to do, I'm just going to think this through a little bit, right? It's f of x plus 1. All right, so I really want to know what that inner function is doing as x approaches 1 from the left. So let's actually graph y equals x plus 1. We don't have to do this. You can just reason it out, but I'm going to do it. All right, here's my graph of x plus 1. I need to approach 1 from the left, right? So I want to know the limit as x approaches 1 from the left of x plus 1. What is that doing? Well, let's do it. There we go. We approach 1 from the left, and you can see that's going to give us 2. But how is it giving us 2? Well, we came from below 2, right? So with y values below, that's equivalent to coming from the left. So we know that we were approaching 2 from the left. So I'm going to rewrite my limit. So it's 0 times the limit as u approaches 2 from the left of f of u. Now let's work out the limit as u approaches 2 from the left. So on the graph of f, I have to approach 2 from the left. Okay, like this. And you can see that that's 2. So we're really doing 0 times 2, which is clearly 0. Now we'll do the same analysis, but from the right. All right, so we start off. G is simple. It's not a composition. You can just look at the graph. We're going to approach +1 from the right, and you can see we get 0 again. And again, if you got 0, like anything other than infinity or negative infinity, your answer is just 0 and you're done. If you got 0 or negative infinity, depending on if you're in Calc AB or BC, in AB, that just isn't going to happen to you. In BC, you might have to use L'Hopital's rule on it, but I'm not covering that in this video, so we're not here for it. All right, so that's 0. Now we have to approach 1 from the right on this composition again, right? We're dealing with this. What is x plus 1 doing as x approaches 1 from the right? That's the question we need to answer. And you can see, I mean, let's do it. We're approaching 2, but from above, and above means from the right. So 2 from the right. So I'm going to put this in of f of u. That's going to be 0 times, now we go to the graph of f, we approach 2 from the right, and you can see you get 4, so 0 times 4, which is 0. Okay, and that means, same answer both times, we get 0 overall. Good stuff. Let's take a look at the next one. So this one's, I think, considerably more straightforward. So we're going to look from the left. Right, so there's a limit as x approaches -1 from the left, 2 times f of x. We're just going to find the limit of f of x and multiply by 2. 2 times f of x plus g of x. So we'll just find the limit of g of x and not multiply by 2. Then we'll add them together. All right, here goes. -1 from the left, which is 0. So we get 2 times 0. I'm a big fan of writing the work. I know not everyone does that. I think it's a good idea. G of x as we approach -1 from the left. We're writing on that horizontal again, so it's just 2. So plus 2. And then we just take the sum of those limits, right? The limit of a sum is the sum of the limits, provided they both exist. Now we'll do the same thing, but from the right. So the limit as x approaches -1 from the right. 2 times f of x plus g of x. So let's take a look at f of x. -1 from the right, on this little horizontal segment here, stays at 1, so that's going to be 2 times 1. And then plus, what is g of x doing? So we need to approach -1 from the right. And you can see that's approaching 0. Plus 0 gives us 2. If you get the same thing both times, then that's going to be your limit. So our limit is 2. All right, so this is the last problem. This problem's potentially a little more challenging. Let's take a look and see. The reason this is a little more challenging is that it's a ratio. And I would say, like, in general, things that involve ratios or rational functions, things that look like fractions, they just kind of like step up your game a little bit. So in this case, if we don't get 0 over 0 by direct substitution, then we're done, right? If we get 5 for the limit of the top and 3 for the limit of the bottom, then the answer is 5/3 and you just move on with life. But that almost never happens because it's not interesting. And so what we need to do is look at the limit of the top and the limit of the bottom. So I'm going to look first at the limit as x approaches 1 of g of x. And I'm going to do slightly worse work on this because I'm hoping that at this point you're feeling how to do these a little bit more, right? So on the graph of g of x, we're going to let x approach 1 and see what happens. So I actually only need a graph of g of x, so I'm going to replace f of x here with another version of g of x. And I'm going to approach 1 from the left and the right. So from the left, I get 0. From the right, I get 0. So I got 0 both times. This limit is 0. Okay, now I need to deal with the limit of the denominator. So 1, g of 2x plus 1. Right, so what are we doing? We're thinking 2x plus 1, as x approaches 1, is approaching 3, right? So we have this inner thing is u is approaching 3. So if from the left and the right, I get the same value as g approaches 3, that'll be my limit. So I'm really doing the limit as u approaches 3 of just g of u. Look at the graph, and if you get the same thing, I'm not going to break it down to left and right. If I got different answers, I'd break it down to left and right so that I could say the limit doesn't exist, but I think 3 from the left gives 0, 3 from the right gives 0. This answer is 0. All right, so what we've really gotten is 0 over 0. That's a L'Hopital's problem. So because we got those, you have to show both of those independently. And then once you have shown those, I can say, therefore, by L'Hopital's rule, the limit as x approaches 1 of g of x over g of 2x plus 1 is equal to, so L'Hopital's is the derivative, well, it's the same limit, but then derivative of the top, which is g prime of x, over derivative of the bottom, which is going to be 2g prime of 2x plus 1. Don't forget the chain rule. Chain rule will get you if you forget it. All right, I'm going to like copy some stuff over so we can actually look at this. So we got everything that I've written so far, and I have a graph of g of x. Now that I'm looking at g primes, all I want to talk about are slopes, right? So at or around x equals 1, what is the slope of g of x? That's really the question that we're talking about for g prime of x. So we look at the graph of g of x around x equals 1, which is here, and you can see that is a line segment that just has a slope of 1. So since the slope is always 1 around there, there's no like spot where we're not differentiable, like a sharp turn or a jump. It's just smooth sailing. That limit is definitely 1 over. All right, now this one's a little different because it's 2 times, so I mean, but that's fine. And then g prime of, what is 2x plus 1 doing as x approaches 1? Well, we already saw that that's approaching 3. So I really need to look at the slope of g at x equals 3 and see what's happening there. So there's going to be 2 times whatever answer I get for this limit. So I'm looking at x equals 3 and dealing with this. So around 3 to the left and the right, smooth sailing, we again get a slope of 1. It's actually kind of a little annoying. It'd be nice if it was different, but you know, they made the problems and good for them. I didn't want to do it. All right, so we have 1 over 2 times 1, and that is going to give us 1/2. And that's it. That's a lot of practice problems, a lot of explanation. People struggle with these a little bit, so I wanted to go through this so that you could watch them. Watch them at whatever pace you want if you think I talk too slowly or too quickly. But anyway, I hope you found this helpful, and good luck.